So when you're looking at order the numbers from least to greatest in Go Formative, you have a typing box. Which of these three numbers would you have typed first? Kendall? Exactly. So 385. Do y'all remember we did this a long time ago? When we're making a list of numbers, how do we separate those? Say just with a comma. Perfect. Comma, space. We want to make sure to put a space because otherwise you're going to be writing a number in the millions. What would my next number be, Tramar?
407.
Good job. 407, comma, space. And last, everybody?
650.
Good job. Not too bad? Okay. Cassandra bought a bag of 900 rocks for her garden. On her way home, 133 rocks fell out. If I stop right there, what is my math word? Fell out. Good. Typically, if something's falling out and we're left, what type of math will we do? Subtract. So what do you notice about our, hold on, our minuend is 900. Minuend is the most. We're starting with 900. What are we going to have to do?
Box.
We're going to have to box because it's 2 zeros and we don't have any to move over. So if you go to the tens place, do we have anything to take? No. So we have to go all the way over and that becomes
89.
And then we can't forget that the zero is becoming
10.
Okay? Is that making sense so far? 10 minus 3 is
7.
Remember 9 minus 3 is
6.
And 8 minus 1 is
7.
How do we check it?
Bottoms up.
Bottoms up. If I do bottoms up, what number do I write first?
726.
Good. 767. And then what's my sign?
Plus.
Because we're doing the opposite. Plus 133. We hope for it to equal, 900. So 7 plus 3? 10. Here's the 1. 1 plus 6?
10.
7 plus 3 is 10. Here's the 1 again. 1 plus 7?
8.
Plus 1?
9.
Beautiful. Okay. If you're looking at the number 900 with this addition problem, what do we call that number?
The minuend. Or the difference.
This time, though, since we're adding, 900 becomes the sum. Up here, it's the
Minuend.
Just checking. All right, our next question says, find the product. Product means that we're going to multiply. 12 times 5?
60.
9 times 9?
81.
5 times 8?
40.
7 times 5?
35.
Whoops. 11 times 3?
33.
Good job. Maria wants to purchase new carpet for her bedroom. Whoops. Her room is 12 feet wide and 10 feet long. How many square feet? Why am I boxing square feet?
Multiply area.
Multiplication. Should Maria buy? So how do we find that number? Multiply. 12 times 10 equals
120.
And remember, if you're looking at that, you can always do this. 12 times 1 is 12. And add a 0 this.
Square feet.
Okay? And then, yes, square feet. Okay? How are the two shapes similar? The word similar means alike. How are they similar, James?
They are both four-sided shapes.
They are. Malaya, what was the word that you put with that description? Yeah, quadrilateral. So quad, lat, Okay, what else? Graham?
They both have lines that would never touch.
Exactly. So they're both parallelograms. And I know that seems weird because only this one has angled lines, but grams. So a parallelogram is a shape that has two different sets of parallel lines. So if you look at this one, will these two red lines ever touch?
No.
They're not. So those are parallel lines. Will these two green lines ever touch? No. So that has two different pairs of parallel lines. Well, let's look at the rectangle. Will those ever touch?
No.
Will those ever touch?
Yes.
Well, they won't either. So the only difference between these two shapes is that the rectangle has
Square corners.
square corners or right angles, whereas the parallelogram does not. It has acute and obtuse angles, which we'll talk about those words more in the next couple of weeks. So those are some good. And you can also say 4 corners. You just wouldn't say that they have the same corners. Okay. Match the pairs of equivalent fractions. Which ones are equivalent? What do you think, Tate? Emmaus? Let's go
Are
ahead.
you talking about the squares or the circle?
The rectangles. What is this fraction to start with? How do we label this, everybody?
3/4.
3/4. So I'm gonna write that here. 3/4. What is this fraction?
4/6.
4/6. The next one?
6/8.
6/8. And the last one?
2/3.
2/3. Okay. What do we think are equivalent fractions, Kyler?
6/8. Well, this seems pretty easy because you gave us the answer. Because it's the blue pair, it's the blue ones, and the red ones.
Okay. He says blue ones and red ones. Let's come over here and crisscross just to make sure. Because we could go ahead and draw these equal lines, but what if my lines are a little bit crooked? How do we prove it for sure? By
What
crisscross.
size?
Yep. So let's take the red ones first. 3/4 and 6/8. 3 times 8.
24.
4 times 6.
24.
Okay, so those are good. And then we're going to take 4, 6, and 2/3. 6 times 2? 12. And 3 times 4? 12. Ooh, sorry. So there were 2 different sets of equivalent fractions.
I told you you gave us the answer.
I did. I mostly did it like that with alternating colors, so that way this fraction in red wouldn't end up looking like the same exact numbers. All right. This one was a little bit tricky. How many 1/4 pieces are there in one whole? Okay, so this right here is one whole. So we're looking down here. How many of those pieces did it take to match up with the whole, Kate? 4. So 4 pieces equaled one whole. And we can show that because 4 out of 4. Now down here, this was the challenge. How many 1/4 pieces are there in 2 holes? So you would have to double this entire thing. What would it be, Jay?
8.
It would be, because in fraction form, you would write it as 8 over
4.
4, which we know is like division, which equals
1/4.
2, because you're looking at it as 8 divided by
2.
4 equals 2.
And
Yeah.
it can also be 1 on 4.
I get 1.
Oh, yes. So tomorrow we're going to have another one like that, where you're talking about 2 holes in challenge mode, basically. Okay.